Okay, we're going to look at the derivative of inverse trig functions. Okay, so that's kind of like saying take the derivative, and we're going to take it with respect to x, of y equals sine of -1 x. Now, this is one way to write it. This means the inverse of sine. There's another way to write the inverse of sine. Do you guys know what that is? Sine, let's see, let's write stuff on the side right here. Sine to the -1, or sine inverse of x, is the same as saying, I don't know if you guys ever heard this before. Maybe you have, arc sine. You guys ever heard that before? Yeah. Okay. Arc sine and sine inverse are the same. I actually like writing this better because this -1 thing right here kind of makes me think it's a power. But a -1 is also used to denote an inverse. So, let me clarify for you really quick what an inverse actually is of sine. It is not cosecant. That's what people think right away because they think of the reciprocal. It is not. Inverse sine is not equal to cosecant. Let me explain why. If you had regular sine, you would plug a theta into it. And we normally use a Greek letter when we plug into trig because the Greek letters usually represent angles, like a measure of an angle. And that would give us opposite over hypotenuse. You guys remember this stuff? Well, if we were doing inverse sine, you're actually not plugging in theta to that. If you have inverse sine, you are plugging in opposite over hypotenuse. And then you would get theta as an answer. Okay, so these are exactly the same equations. They're exactly the same. But this one's using the inverse sign, this one's using a sine. A regular sine, you plug in theta, you get the sides. An inverse sine, you plug the sides in, you get your theta. Okay, so that's what an inverse trig function does. So how can we take the derivative of this? Now there is a formula that you can just memorize, but how do we get it? So I want to walk you through a very simple logical proof to help you guys see. It's not going to be very formal, but it'll be logical with the steps and everything. To help you guys to see how we can take the derivative of this. Now right now x is inside of this inverse trig function, which means when we do like the chain rule, we take the derivative of sine to the -1 or inverse sine. We don't have to really take the derivative, multiply our answer to the derivative of x because the derivative of x is just 1. Alright, so got that out. Now let's do this. Alright, so I'm going to kind of manipulate this a little bit. Instead of looking at it as inverse sine, I'm going to look at it as sine y equals sine or equals x. So I'm kind of just changing it around a little bit because we're familiar with sine, we're not familiar with inverse sine, and I'm going to take the derivative of this.
Wait, why'd you do that?
Well, think of it like this. Let's say I took sine of both sides. I said sine of y, and then on this side I said sine of sine inverse of x. And if I did that, sine and sine inverse would cancel each other out because they're inverses of each other. Kind of the same idea as multiplication and division. Those are inverses of each other, they undo each other. Addition and subtraction, those are inverses of each other, they undo each other. So these would essentially just cancel out, and I would be left with x on the right side, which is what I have right here, and on the other side I have sine of y. Now, why did I do that? Because a while back we proved how we can find the derivative of sine. And so now we have a little formula that we know. What is the derivative of sine? Cosine. Quite simple, yes. So the derivative of sine is cosine. And then you keep what's inside. But then you have to multiply this by the derivative of what's inside. Says the chain rule. On the other side, and I have to do that because I'm not taking the derivative with respect to y, I'm taking it with respect to x. On the other side, when I take the derivative of x, it's just a 1. But I don't have to do a chain rule or anything like that because I'm taking the derivative with respect to x. So if I want to find my answer, I got to get this y prime alone. Okay, it just says y prime, so, and I've also seen it written as dy over dx, which you guys know is the same thing. But I'm going to leave it as y prime for now because I think you guys like that better. So what does y prime equal? Y prime equals 1 over cosine of y. Now, I don't want cosine of y there because that would be weird if I was just to only take the derivative of sine, inverse sine. Like, what if I was just doing this? It wasn't like a equation. I just need to take the derivative of this. And all of a sudden I have a y in there? Like, what the heck is that? So we got to rewrite this somehow. So I'm going to use something you guys are very, very familiar with. And if you're not familiar with it, I don't know why you're in here. We have sine of squared y plus cosine squared y. You guys know this guy? You should be familiar with him. All right, I want to get rid of this cosine, and I want to put sine back in there because I'll show you why. It's kind of neat. All right, so let's move that sine squared y to the other side. So now I have cosine squared y equals 1 minus sine squared y. And then I would square root both sides so that the cosine wouldn't be squared anymore. And I would have cosine y equals the square root of 1 minus sine squared y. So over here I can substitute that in for my cosine. So let's see what that looks like. We have 1 over the square root of 1 minus, now I'm going to write this slightly different. I'm going to say sine y and square it on the outside. Okay, now how am I going to get rid of this sine y? Does anybody know? Someone did first period and I was pretty impressed. Sine y. What does sine y equal? You go back into work that we have. Yep, it's right there. What does sine y equal? It equals x. So I can actually rewrite this as 1 divided by the square root of 1 minus x squared, which is going to be our answer. If we were to take the derivative of the inverse of sine, we get 1 over 1 minus x squared, and we take the square root of that. That is the whole purpose of this. Knowing that. Memorize it. Or do this proof every time. Yeah, memorize it's better. Let's do an example of this. Let's take the derivative of, or actually we can just do it like this. Let's take the derivative of inverse of sine, or you can write arc sine if you wanted to. You want to try something different. And inside of it, let's put I don't know, 5x squared plus 1. Whoa, that's weird. Okay, so I'm going to take the derivative of this. Ooh, that's nasty. All right, chain rule says that we take the derivative of the outside function first, and then we multiply it times the derivative of the inside function. So we know the derivative of this. Except look at this craziness inside. You see over here it says the derivative of inverse sine of x is this. So whatever's inside of the inverse sine, you have to square it right there. So this is what it would look like. I would have 1 over 1 minus, and then I'm going to have 5x squared plus 1. Square that, and then square root of that. Oh man, this is dirty. And we have to multiply this by the derivative of the inside. The derivative of the inside is just 10x, which actually we could just put up there with the 1 if you wanted to. So our answer is 10x over the square root of 1 minus 5x squared plus 1. And that's as far as I'm going to take this. I'm not going to go any farther. I just wanted you guys to see the chain rule with the formula that we just proved.